Hello everyone, we are going to be starting, we're going to be doing today question 4. Alright, we did already question 2 and question 3, we're going to go on with question 4. Now question 4 is about work, energy and power, and I did make previously couple of videos on this topic. So please, before you answer the question, if you struggled, you can go to one of those videos. I will leave the link of each video in the comment, alright, in the description of the video. So let's start with this one, and this one say an 8 kilogram block is moving along a horizontal surface at a velocity of 7 meters per second to the right. When it strikes a rough surface at point A, the block slides 2 meters from A to B, while experiencing a constant frictional force of 20 newton to the left. The force then moves up a ramp incline at an angle of 30 degrees to the horizontal as shown in the diagram below. The block moves a distance of 1.2 up the ramp before it comes to rest. And there is the sketch of the situation. Let's read once more and highlight some data that might not be in the sketch. They say an 8 kilogram block is moved along a horizontal surface at a velocity of 7 meters per second to the right. There you have the data of the block. It's 8 kilograms and it's moving to the right at 7 meters per second. It's shown in the diagram. When it strikes a rough surface at point A, there is friction at point 8. And let's write it down, because it is actually given to you, so with a constant frictional force of 20 newton. So the frictional force here is equal to 20 newton. Now let's clarify something. This frictional force on this point is not going to be the same as the frictional force here. The frictional force on the incline is different because the normal force is different. So the 20 newton for the frictional force is only from A to B. And I'm going to write it here just for you to know. The frictional force AB is not equal, it's different from the frictional force BC. You might not need it in the whole question, but it's just for further questions, other ones, okay? This might not be needed, but you cannot use the 20 newton for the ramp up because it's different. Why is it different? Because the normal force is going to change due to the angle of 30 degrees, okay? But we're moving on. The block then moves up a rough incline at an angle of 30 degrees with the horizontal as shown in the diagram below. The block moves a distance of 1.2 meters up the ramp before it comes to rest at point C. So the velocity here is equal to 0. Okay, I think that is the most important data. We're going to go on and then we'll see what happens. So let's start with question 4.1. State the work energy theorem in words. So let's solution. Let's start with 4.1. State the work energy theorem in words. We already stated this one many times, but let's do it once more. Okay, the work done on an object, or by the let's fix it, the work done by the net force on an object is equal to the change in kinetic energy. Right? This is the work energy theorem in words. Now, there are two marks for this equation. The work done by a net force, important here, the work done by net force. Work done by net force is the same as saying the word net. So you can say work net, and you will get still the mark, okay? Work done by the net force is the same as work net. On an object is equal to the change. Many learners forget to write the word change, and then you are not going to get the mark. So it's not just equal to kinetic energy, it's equal to the change in kinetic energy. If we write that one in a formula, the work done by the net force is equal to the change in kinetic energy. And let me show you something. You can go to the formulas in the question paper when they say, where is it? Here are the work energy and power formula. You see, I'm just in the formulas of the question paper. You can see here right on the top right hand side, let me just move it up so you can see it. Here you can see the work energy theorem. There is the work energy theorem. All you have to do is to identify where is it and then write it down inward. The net work is equal to the change in kinetic energy. Alright, and then there are 2 marks for that one. Let's just write the marking. There is 2 marks for that one. Now, important to know again, work done by the net force. If you don't write the net force or you don't write the net work, you don't get the mark. If you don't write the word change in kinetic energy, you don't get the mark. Okay, let's try to keep these easy marks as they are. Okay, now let's go to question 4.2. Now 4.2 said use the work energy theorem to calculate the speed of the block at point B. You cannot use any other solution apart from the work energy theorem. All right, so let's quickly for 4.2 let's draw the free body diagram very quick. Remember, we are working with point AB. All right, so at point AB the surface is horizontal. Let's draw the axis. I remember I like the axis, and this is going to be the x-axis as well as the displacement, just for the angle. And then the y-axis is perpendicular to the x. This is y. Is the object. Then what forces are acting on that block? Well, frictional force on the x-axis. There is gravitational force or weight, and there is normal force. So those are the forces that act on that object. Alright, so let's start now by writing the work energy theorem in symbols. Now, net work is equal to change in kinetic energy. Remember, net work is the algebraically addition of the work done by all the forces. So the forces are those 3 there. I'm going to write the addition of the work done by each force. Work done by frictional force plus the work done by the normal force plus the work done by the gravitational force is equal to change in kinetic energy is final minus initial. So it's half mass multiplied by the speed final to the power 2 minus half multiplied by the mass multiplied by the initial speed to the power 2. Alright, this is the work energy theorem. Now, we don't have any of the forces. You can either substitute here in the same formula, or you can calculate it apart. I think it's better to calculate it apart. Might be more work, but if somebody struggles, might be easier for them. Alright, so we're done by the frictional force. We're done by the frictional force is equal to frictional force multiplied by displacement multiplied by cosine of 180 degrees. Remember, for frictional force, the displacement is the angle between the displacement and the force is always 180. We do have the frictional force. Let's go back here. In the data is 20. Remember, always go back to look for the data. It's 20 multiplied by the displacement, which is given. The displacement is 2 meters. We are here, AB. It's 2 meters. Multiplied by cos of 180 degrees. Now, let me probably say something that I noticed with my learners. The work done by frictional force, you cannot write here the negative. The negative is coming because of the angle of 180. So you cannot write minus work done by friction. These are not vectors. So the minus will come later, and the meaning is no direction. So please, let's not make that mistake. You cannot write minus frictional force, because when you multiply this minus by the minus of cos 180 will give you positive, and it is going to be wrong. The work done by the frictional force is going to be negative because it's taking energy away from the system, and will come negative because of the cosine of 180. So do not write the negative at the front of friction of the work done by frictional force. Right? Let's take it off, and then please take that note. Okay, this one is quite easy. Cosine of 180 is minus 1. 20 times 2 is 40. So the answer for the work done by the frictional force is equal to minus 40. Sorry, let's pick the 40. That's not the 40. Minus 40 joules. Right? This is the work done by frictional force, and that will be substituted there. As it is with the negative, you cannot write negative work done by frictional force. Okay, now the work done by normal, everyone, if you watch the previous videos, it won't be a problem for you, it shouldn't, but let's show you quickly here. Let's show you anyway. Work done by the normal force is equal to normal force multiplied by displacement multiplied by cosine of, let's look at the angle. Let's go free body diagram. Displacement is to the right, then you can see the displacement. The angle here is 90 degrees, and probably we're going to do this one is also 90 degrees. So the work done by cos of 90 degrees, work done by the normal force is this one, cosine of 90 degrees 0, therefore the work done by normal is 0 joules. Same with the work done by gravitational force is equal to the product of gravitational force multiplied by displacement multiplied by the cosine of 90 degrees, which is 0, so the work done by gravitational force is 0 joules. Alright, now you don't have to substitute the 0 if you don't want, but you can. Okay, so let's substitute everything. So you can see it. Work done by frictional force, and now I'm going to this equation again. I'm going to substitute the numbers on that equation. Now here we have minus 40 plus 0 equal to half. The mass is, let's go back to not make mistake, is 8 kilograms. 8 kilograms multiplied by the final speed to the power 2. This final speed to the power 2 is the speed with which the block is going to arrive at this specific point. That is what we are looking for. Right? What is the speed of the block at that point? Okay? Which in this case is the final for AB. Minus half multiplied by 8, which is the mass, multiplied by the initial speed of the block, which is 7, starting with 7 right there. Okay, let me just, don't you think it's a negative, it's a 7, that is the starting speed of the block, so multiplied by 7 to the power 2. Okay, so everything left here is just calculation. Let's do it step by step, and we have here minus 40 equal to 8 divided by 2 is 4, multiplied by final speed to the power 2, and then minus, let's do that calculation real quick, is just for you to see it. Let me clean the history here. So is 8, let's say 7 times 7 is equal to 49, times 8 is equal to 392 divided by 2, and that is equal to 196. Okay, so we're going back here, and it's minus 196. All right, there you go, 196. Now if you rearrange this one, this 196 is going to the other side, to the left hand side, and then the 4 is coming dividing. So if you do it step by step, you have that 196 minus 40 is equal to 4 multiplied by v to the power 2. So 196 minus 40, let's do here, minus 40 is equal to 156. 156 divided by 4, and the square root of all that. That will be equal to v. Okay, this is simple math. It's not a difficult calculation. So let's see if our calculator help us to do this calculation. It's 156 divided by 4 is 39, and then will be the square root of 39, which is the answer, and that gives us 6,24. So the answer is 6,24 meters per second. Do not forget the unit. This is the answer of the question they ask for. Alright, so the only option to do here is work energy theorem, because they said they want the answer be done with the work energy theorem. Now, where is the marks allocation here? The marks allocation are 1 mark for any of those, either one mark for the entire substitution, which means you need to have this substitution here right, as well as this one here right. So the whole substitution will get 1 mark. Alright, and then 1 mark for the final answer, and that will give you 3. Okay, now let's go to the next question. Let's go to the next question, and the next question said, calculate the work done by the non-conservative force acting on the block from B to C. Remember, what is a non-conservative force? It's a force from which the work done in moving an object depend on the path taken. Remember, forces could be conservative and non-conservative. In this case, the non-conservative forces are the frictional force and the normal force. Okay, now let's go to 4.3. Now 4.3, we're working on the incline, right? So let's do the free body diagram. On the incline, this is the x-axis and it's also the displacement for us. Okay, and then perpendicular to that axis is going to be the y-axis. Then what forces are there? There is frictional force acting on the block, frictional force. There is a normal force. Normal force, the angle is still 90 degree. I'm just going to show you here quickly. This is 90 degree. Therefore, the work done by normal force is equal to 0. Okay, so we're going to keep it out for now. And then the other force is gravitational force. Remember, gravitational force is straight down. That is gravitational force. Okay, if you want, you can draw the component of the gravitational force. However, it's not going to be needed right now because we are not dealing with Newton's law. Now, the angle between the displacement and the gravitational force is all this one. This is the angle between the gravitational force and the displacement. So this one here, the small one here at the bottom, let's do it with blue. This one here, this small angle there, it's not nice like that. So let's go back and let's just use the pen. This angle here, this angle there is equal to 30 degrees. That is the same angle as the inclination, right? It's 30 degrees. So what is going to be the angle between the gravitational force and the displacement? Is going to be 90, which is this part here, plus 30 degrees. That is the angle between the gravitational force and the displacement. We are going to use this one a little bit later. Okay, now the one that were done by the non-conservative forces. Okay, so let's start by that one, which is option 1. We are going to explain to option 1. We're going to use the law of conservation of energy. Remember, that one says that the work done by the non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. That is one option. What is the non-conservative forces here in this situation? Is the frictional force. So we are trying to look the work done by the frictional force. Okay, so now if we go on here, we can break this one further. We have that the work done by the non-conservative forces is equal to change in kinetic energy will be half mass final speed square minus half mass initial speed square. That is the change in kinetic energy plus a change in potential energy is mass multiplied by acceleration due to gravity final height minus mass multiplied by the acceleration due to gravity initial height. Right? So this is the same thing, just a little bit with more substitution. Now we have all the data, so we can substitute everything here. The work done by the non-conservative forces is equal to, and let's start substituting everything. Now we're working with the incline. We're working with this part here. The final speed is 0, all right, and the initial speed is what it was calculated here, right? So the final speed is going to be 0. And then if you want, let's substitute everything. Half multiplied by 8 multiplied by 0 to the power 2, which is going to be 0 everything, minus half multiplied by 8 multiplied by initial speed to the power 2, and the initial speed was calculated here. So it's 6,24 multiplied by 6,24 to the power 2. Plus, now we're going to the change of the, here is a double bracket. Let's fix this bracket so you don't make mistake. That is a bracket for the change in kinetic energy plus open bracket. Here is mesh, which is 8 multiplied by 9,8 multiplied by the final height, which is the height of the incline, and is given as no, the height is not given. No, the height is not given. Would. So we have to calculate the height. I thought the height was given, and then we have to calculate the height. Let's go back here quickly and do the following. We don't have that height. Okay, so let's calculate that height real quick, and it's going to be sorted here. Now we have this situation. This is good. I explained in one of the video, but I thought here the height was given. So it's 30. This is 1,2. You're looking for height. You can say from here that sine 30 degree is equal to opposite side, which is height, divided by the hypotenuse, which is 1,8. If you rearrange this one, you get that the height is equal to 1,8 multiplied by sine 30 degree. That is the height. And if we calculate, we can say it's 1,8. Let's go to our calculator. It's 1,8 sine sine 30 degrees, no 300, sorry, 30 degrees. Okay, this is equal to 0,9. 0,9, or you can substitute already the everything if you want. 1,8 multiplied by the sine of no, it's not 1,8. Sorry, it's not 1,8. It is 1,2. Why did I write 1,8 here? I'm very sorry about that. You must make sure you check the numbers properly. Yeah? It's 1,2. There you can see it's 1,2. I'm sorry about that. So it's 1,2. Let's fix here. This one is 2. 1,2. So it's 1,2 multiplied by the sine of 30 degrees. It's 0,6. That is the correct one. 0,6. Alright, so the height is 0,6. Let's write the meter here so you can see it. So this height is going to be substituted in there. Alright, let me just write with the same color. 0,6. You can either write 0,6 or you can write the complete as it is here, 1,2 multiplied by sine of 30. And will give you the same answer. Okay, now the everything minus 8 multiplied by 9,8, that multiply the initial height, and the initial height is 0. Is when it's at the bottom of the ramp here. There is not height, so the height there is 0. So it's the product multiplied by 0. All right. So all this is going to be 0, and all this is going to be 0. All right. So what we have left here, we're done. By the non-conservative forces is equal to, and let's do this calculation, which is negative. So let's do that calculation. Is 6,24 to the power 2, which is 3,9376 multiplied by 8 divided by 2 is 155,75. 155, sorry for the eraser, 155,75 plus 8 times 9,8, 8 times 9,8 times the height, which is 0,6. 0,6, and the answer is 47,04. The answer is 47,04. Alright, so now the final answer will be 155,75 minus 47,04. 155 75 minus 47,04, 108,71. 100, it's negative because the bigger number is negative, 108,71 joules. That is the work done by the non-conservative forces. And yes, it must be negative because it is taking energy away from the system. Alright, so this is option 1. If you use this option, the marks will be allocated as 1 mark for either of these two, which is the same, 1 mark for the entire substitution, which you don't have to substitute the zeros. So this one already could be 0 there if you want, and 1 mark for the final answer. Okay, this is option 1. Now option 2. Option 2 is using the work energy theorem. Okay, option 2 is using the work energy theorem, and that will be the net work is equal to the change in kinetic energy. What forces are acting here? There is the normal force, the frictional force, and the gravitational force. So this will be the work done by frictional force plus the work done by normal force plus the work done by gravitational force is equal to half mass final speed square minus half mass initial speed square. Now remember, the work done by the frictional force, that is the work done by the non-conservative forces, which is what they're looking for. Okay, the work done by the normal force is 0 because still the angle between the displacement and the normal force is 90 degrees. Alright, so this is 0, and the work done by the gravitational force. So this will be plus the work done by gravitational force is, let's calculate it separate. Let's keep our trend of calculating the work done by forces separately. So this one is going to be the work done by the gravitational force is equal to gravitational force multiplied by displacement multiplied by the cosine of theta. Sorry. So this is the product of mg displacement cosine of theta, and remember at the beginning we managed to see theta is 90 plus 30. Okay, so theta is 90 plus 30, which is 120 degrees. Okay, if you substitute here, you have 8 multiplied by 9,8 multiplied by 1,2, which is the displacement, multiplied by cosine of 120 degrees. Okay, so we can do that calculation real quick. Let's show you here real fast. That calculation is 8 multiplied by 9,8 multiplied by 1.2 multiplied by the cosine of 120 degrees, and the answer is negative 47,04. Negative 47,04 joules. That is going to be substituted in that. Alright, so we can do the whole substitution. It's there so you can see it. Now we have the work done by the non-conservative forces, which is the work done by the frictional force minus 47,04 is equal to half multiplied by 8 multiplied by final speed, which is 0, and the maximum height, remember, multiplied by 0 to the power 2 minus half multiplied by 8 multiplied by the initial speed, which was calculated. It is 6,24 to the power 2. So this is the other option, or everything here is equal to 0. If we do the calculation, we have that the work done by the non-conservative forces minus 47,04 is equal to, and this calculation was done already, but let's redo it, is half 8 multiplied by 6,24. So it's 6,24 to the power 2 multiplied by 8 divided by 2. That is 155,7504. So 155,75 negative 155,04,75, sorry, 0.75. So work done by the non-conservative forces is equal to 100 negative 155,75 plus 47,04, and that will give you the final answer, which is exactly the same as you see here. It's the same calculation, so I'm not going to redo it. It's negative 108, so the work done by the non-conservative forces is negative 108,71 joules. If you use this method, you will get the marks allocated in the same way as the previous one. So you get 1 mark for this part here, either of the two formulas. You get 1 mark for the entire substitution, and you get 1 mark for the final answer, and that is 3 marks. Okay? Now, the final question of the problem is quite easy. They say, is mechanical energy of the block conserved from A to C? Remember, the law of conservation of mechanical energy states that in a closed or isolated system, the total mechanical energy is conserved. However, the system is not closed. There are non-conservative forces. There is friction present. So the answer, the best answer, the easiest one, is to say no, and that is 4.4. The answer will be no, and I will say the system, let's fix that beautiful Y, the system is open, or you can say the system is not closed. Then you get 1 mark for saying no, and 1 mark for saying system is open. Okay, you add is 5, and then 3 plus 2 is also 5. The total is 10 marks. Okay, so the total is 10 marks. This is total. Thank you very much. This is the question on work, energy, and power. Make sure you answer the question before, and then use the solution to mark your response. Okay, thank you very much. Question 5, we're going to be solving question 5 next time, and question 5 is regarding Doppler effect. Thank you very much. I hope it helped. I'll see you next time.